Hello, welcome to Science for Everyone with Tom Copeland. I'm Tom Copeland. Let's get down to science. And just remember, science is for everyone. So for today, we're talking about types of chemical reactions. We have 5 types we're going to discuss. We have synthesis reactions, decomposition, single replacement, double replacement, and combustion. And I guess I got a Super Mario theme going on here for you, so enjoy that. Very creative right here, very creative. Okay, so the first type of chemical reactions we're talking about are synthesis reactions. So the word synthesis means to make, right? Combine. Photosynthesis, right? To make from light. So if we look at this formula, we have A plus B. This arrow means that a chemical reaction is occurring, and AB is the compound. So in synthesis reactions, we have 2 smaller elements that combine and form a compound. So the left-hand side of a chemical equation is known as the reactants, and the right-hand side is known as the product side. So we have our reactants, A plus B, and the product is AB. So with synthesis, we have 2 smaller elements, and they form a compound. This is an actual, chemical equation, and I don't have any of these equations, balanced because I don't want you to be confused. I just want you to look at the type of reactions in this video. But later I am going to have some videos about balancing out these equations. So let's look at this. Hydrogen plus oxygen forms H2O. We have hydrogen gas, oxygen gas. They combine and make a compound, water, right? This would be similar to if we have Luigi and Mario, and they form to make the Super Mario Brothers, people. So I think synthesis is probably easy to recognize. You have 2 smaller elements form a compound. 2 littles make 1 big. Okay, let's look at decomposition reactions. This is kind of just the opposite of a synthesis reaction. So if you think of A plus B forms AB, this is kind of a great analogy. A likes B, A asked B out on a date, and now AB is a couple or a compound, right? But decomposition is the breakup. So here you had your couple, they got into an argument or something, and they broke up, and now they're single again. So this is exactly what happens with a decomposition reaction. We have a larger compound as the reactant. We have a chemical equation, so a chemical reaction occurs, and then A plus B are single elements again. So this is an actual chemical equation. Silver oxide breaks down into silver plus oxygen. So again, we had this larger compound, 1 big, and it broke down into 2 smaller either compounds or elements. And sometimes you can actually have it break down into more than 2, 3, sometimes even 4. So this would again be, you have the Super Mario pizza, and you get 6 slices for Mario, 5 for Luigi, and you get 1 slice. So this is decomposition. Okay, let's look at single replacement reactions. This is where one element replaces another in a compound. There's no crying in chemistry though, people. So don't get upset with this analogy. Let's say B and C are a couple, they break up. A is a best friend. A just swoops in there, and now AC is the new couple or compound, and B is single or the single element. So, right, this is the formula again, A plus BC. This arrow means a chemical reaction occurred, and then we end up with AC plus B. So basically what happens is one element is going to kick the first element out of the compound, and it's going to replace it. This occurs due to activity series, which that's going to be a different video. But if we look at this, we have potassium iodide and we have chlorine. And what's going to happen is the Cl, the chlorine, is going to kick out the iodine, and we're going to end up with potassium chloride and then just iodine. So this is single replacement, where one element replaces another element in a compound, and that element is no longer in that compound, and it's usually existing as a single element again. Okay, let's look at double displacement reactions. This is the formula. AB plus CD forms AD plus CB. I know this gets a little confusing, but essentially the front, elements in the compound, they switch places. So here we have barium chloride and sodium sulfate, and in the end we have barium sulfate and sodium chloride. You can also think of it as the back half of those compounds are also switching. It's usually the front part of the compound, since it's an ionic compound where you see double displacement. The front part of the compound is going to be a metal. So barium's a metal, sodium's a metal. The second half of the compound is going to be a nonmetal or a polyatomic ion. And a lot of times what occurs is you have the formation of something called a precipitate, which this is a insoluble compound, which means that it cannot dissolve in the new solution. So you're actually going to see the formation of a precipitate, which is solid, and you will see this during the reaction, and sometimes it's really cool. So again, double displacement, the front part of the compounds, which is usually the metals, are going to switch places. I don't have an analogy for this one because it would get complicated. Okay, last one, we have combustion reactions. So this is a special type of reaction, and it's always with a hydrocarbon plus oxygen. Then we have the chemical reaction, and the product is carbon dioxide and water. I would add a third one, and that would include heat, because it's giving off energy. This is an exothermic reaction. It doesn't always have fire involved, even though it's combustion, but it does give off heat always. It's exothermic. So it's easy to identify this because it follows this formula. You have a hydrocarbon, which in this example, we have methane, we have oxygen, and then the products are going to be carbon dioxide and water plus energy. This is why we have climate change, because we have a lot of combustion reactions. Every time we drive our cars, factories, anytime we have any fossil fuels burning, right? You're heating your house, natural gas. So really, climate change is due to just a simple chemical reaction that we keep doing over and over again. So I hope this has been a helpful video for you, and that you understand the 5 types of chemical reactions. And just remember, science is for everyone. And I hope you enjoyed this video. If you do, say hello, subscribe, and keep watching.